Welcome to the world of industrial innovation. Here, cutting-edge technology meets precision engineering to transform raw materials into products that power our modern world. In this comprehensive journey, we'll explore the fascinating processes that happen behind the scenes in state-of-the-art manufacturing facilities. This facility represents the pinnacle of modern industrial engineering. Spanning acres of carefully designed space, it houses sophisticated machinery and equipment that work in perfect synchronization. The complex network of conveyor systems, crushers, separators, and processors you see here operates with remarkable precision and efficiency. At its core, this facility is designed to process vast quantities of material daily. The operation begins with raw materials being fed into the system. Each component of this facility serves a specific purpose in the overall production pipeline. The conveyor belt systems are among the most critical elements, moving materials through various stages of processing. Notice the intricate arrangement of equipment. The crushing machinery is positioned strategically to handle different material sizes and compositions. Advanced sensors and monitoring systems ensure that every step of the process meets strict quality standards. The facility operates continuously, running 24/7 to maximize productivity and efficiency. The infrastructure visible here took years to develop and refine. Engineers worked tirelessly to create a system that could handle the demanding requirements of modern manufacturing. Safety is paramount in every design decision. The elevated walkways, safety barriers, and protective equipment are all carefully integrated into the facility's layout. Let's examine the primary processing systems that define this operation. The crushing units you see are engineered to break down materials into precise sizes. Each crusher operates at optimal speed and force to achieve the desired particle size distribution without damaging the material properties. The conveyor systems are marvels of engineering efficiency. They move materials continuously through the facility, maintaining perfect alignment and speed consistency. These belts are made from specialized materials designed to withstand constant friction, impact, and the weight of heavy materials. Regular maintenance ensures they operate smoothly without interruption. The separation systems are particularly fascinating. Using gravity, vibration, and air currents, they classify materials by size and density. This sorting process is crucial for downstream applications. The technology ensures that only materials meeting specific criteria proceed to the next stage. The dust collection systems are equally important. They prevent environmental contamination while recovering valuable material that might otherwise be lost. Advanced filtration technology captures fine particles, which are then recycled back into the production process. This creates a closed-loop system that maximizes resource utilization. Heat treatment and processing equipment visible in the facility represents significant technological investment. These systems can process materials at various temperatures and pressures depending on the specific requirements. The molten material handling you see requires extreme precision and safety measures. The processing of materials through heat and pressure demonstrates advanced industrial chemistry. When materials are heated to extreme temperatures, they undergo transformation. The skilled operators manage these processes with careful attention to every parameter. The material receiving its treatment here undergoes significant changes. Color transformation, density changes, and chemical composition modifications all occur in a controlled manner. The yellow glow you observe indicates the material has reached the required temperature. This visual indicator helps operators maintain quality consistency. Specialized equipment guides the material as it flows from the heat source. The careful control of flow rate ensures uniform treatment across all material. Any variation could affect the final product quality, so precision is essential. The cooling process is just as important as the heating process. Materials must cool at a controlled rate to achieve the desired properties. Rapid cooling or slow cooling produces different results, so the cooling systems are carefully calibrated. The collected material demonstrates the process effectiveness. The pellets or granules produced represent the final product of this stage. The consistency in size and color indicates successful process control. These materials will be further processed or shipped to customers, depending on their specifications. Modern manufacturing employs advanced techniques that weren't possible just a few years ago. The polymer processing equipment visible here can handle various material types. The blue-colored pellets represent plastic material being processed into precise shapes and sizes. The extrusion process forces material through specialized dies, creating uniform shapes. The size consistency achieved through modern extrusion is remarkable. Each pellet is virtually identical to the next, meeting strict dimensional tolerances. The cooling systems for processed pellets are highly sophisticated. Water spray systems or air cooling can be employed depending on the material properties. The controlled cooling prevents warping or deformation. The collected pellets demonstrate perfect uniformity. Quality control systems continuously monitor the process. Each pellet is visually inspected, and samples are regularly tested for mechanical properties. Any deviation from specifications triggers automatic adjustments to the process parameters. The material handling systems ensure processed products don't get damaged during collection or transport. Gentle conveying methods prevent crushing or deformation. The final product is carefully packaged for shipment, maintaining the quality standards achieved during processing. Operating a facility of this scale requires exceptional coordination and planning. The control room monitors thousands of data points every second. Computers and automated systems make real-time adjustments to optimize performance. The workforce in this facility consists of highly trained professionals. Equipment operators understand the nuances of their machinery. Maintenance technicians ensure peak performance through preventive maintenance schedules. Quality inspectors verify that products meet all specifications. The efficiency metrics achieved by modern facilities are impressive. Processing capacity, waste reduction, and energy efficiency have all improved dramatically. The investment in technology and training pays dividends in improved performance metrics. Safety protocols are rigorously enforced throughout the facility. Every employee receives extensive training on proper procedures. Regular safety audits identify potential hazards before they become problems. The safety record of well-managed facilities like this one is exceptional. Energy management is a critical consideration in modern manufacturing. Advanced equipment operates more efficiently than older alternatives. Heat recovery systems capture thermal energy that might otherwise be wasted. Optimized lighting and climate control systems reduce overall energy consumption. The production scheduling is carefully planned to maximize efficiency. Raw material arrives in coordinated shipments. Processing is scheduled to maintain optimal facility utilization. Finished products are dispatched on carefully planned schedules. Quality assurance is embedded throughout every aspect of this operation. Regular testing verifies that products meet exacting standards. Mechanical property testing, dimensional verification, and visual inspection all occur continuously. The testing laboratories within the facility are equipped with state-of-the-art instruments. Hardness testing, tensile strength analysis, and composition verification confirm product quality. These tests ensure consistency batch after batch. Documentation is maintained meticulously for every product batch. Traceability systems allow any product to be tracked back to its source materials and processing conditions. This accountability ensures quality transparency. Customer requirements drive many of the specifications maintained in this facility. Different customers may have different requirements, and the facility must adapt accordingly. Flexible manufacturing systems accommodate this variety. The commitment to quality extends beyond the final product. Process efficiency, waste reduction, and continuous improvement initiatives all contribute to overall excellence. The facility represents the best practices in modern industrial manufacturing. This comprehensive facility demonstrates the sophistication of modern industrial manufacturing. The combination of advanced technology, skilled workforce, and rigorous quality standards creates products that power industries worldwide. From the moment raw materials arrive until the finished product ships, every step is optimized for excellence. This is the foundation of modern manufacturing: innovation, precision, and dedication to quality.